Hi students, now we'll start exercise 1.3, question number 1. Question number 1 says, prove that root 5 is irrational. To prove root 5 as irrational, we assume that it is a rational number. Let us write down that let root 5 be rational. If it is rational, then it should agree that it is equal to a by b, where a and b are co-primes. I think you know what is a co-prime number. Here, if a and b are co-prime numbers, then they should have one as common factor, only one. No other factor should be common. If we prove that, then root 5 becomes rational. If we cannot prove, then root 5 definitely is irrational. Okay, let us now proceed. What we do, we have one more condition here. B should not be equal to 0. If it is 0, then it is undefined. Now, we'll square both sides. Squaring both sides, that is root 5 whole square and a by b whole square. Root 5 whole square becomes 5, and here it is a square by b square. We transfer b square to the LHS. It becomes 5b square equals a square. This will mean that a square is divisible by 5. A square is divisible by 5. If a square can be divided by 5, then a also is divisible by 5. Now, in the next step, we will take a equal to 5 into c. This c is any integer. A is equal to 5c, where c is any integer. That is the next step. What we do now, we will substitute the value of a in this equation. By doing so, 5b square equals 5c whole square. In the place of a, we put 5c and squaring them. This becomes 25c square. 5b square becomes 25c square. Here also, we understand that b square is divisible by 5. If b square is divisible by 5, as per this equation, b also is divisible by 5. I can say this as case number 1 and this as case number 2. Right? Now, we have observed that in this case a is divisible by 5, and in the second case b is divisible by 5. Now we will proceed. If a and b are divisible by 5, that means 5 is a factor or a common factor of a and b. Now this is one sentence which proves that we have assumed wrong. If a and b are co-primes, that should not have any other factor as common other than 1. But here we have proved that 5 is a common factor. Therefore, a and b are not co-primes. If they are not co-primes, root 5 is not a rational number. Our assumption is wrong. Therefore, we finally conclude that root 5 is irrational number. This is our answer. Well friends, now we are going to solve the question number 2, which says, prove that 3 plus 2 root 5 is irrational. As I said, to prove that it is irrational, we have to first assume that it is a rational number. Let us write down. Let us assume 3 plus 2 root 5 a rational number. If it is a rational number, then it should be equal to a by b, where a and b are coprimes and b should not be equal to 0. I'll explain why. A and b are coprime means they should have only one common factor, that is 1, not other than 1. And b should not be equal to 0 because if it becomes 0, then this becomes undefined fraction. Okay, the next step is, let us take out 3 to the RHS, then it becomes 2 root 5 equaling a by b minus 3. Root 2 root 5 is equal to, let us take b as LCM, a minus 3b, 1 b times and b into 3 is 3b. Transfer 2 to RHS here, root 5 remains there, and a minus 3b divided by 2b. When this comes this side, RHS side, 2 takes the denominator place. Therefore, root 5 is equal to a minus 3b by 2b. Now we know very well the fourth thing here, RHS, that is a minus 3b by 2b, is rational number. It is rational because a and b, they are all integers and 3 to again integers. Therefore, it is rational. We also know that root 5 is irrational, which we have done right now, irrational. We know that root 5 is irrational. We know both. Now here, rational can never be equal to irrational. Root 5 cannot be equal to a minus 3b by 2b. Now this is proved. That means somewhere we went wrong. Where we went wrong? In the assumption. We are wrong to assume that 3 plus 2 root 5 is rational. Our assumption is wrong. Therefore, 3 plus 2 root 5 is definitely irrational. This is our answer. Now moving on to the third question. This third question says, prove that the following are irrationals. There are 3 sub-questions. It is very easy now, as we already done 2 questions and we started assuming that the given question numbers are rational numbers. Similarly, we start now here also. The first question is 1 by root 2. So we assume, let us assume that 1 by root 2 is rational. The moment you say it is rational, that should agree, should be equal to a by b. Here, a and b are coprimes, meaning that they have only 1 as common factor and no other factor should be common. And b should never be equal to 0. Now we simplify taking cross multiplication. A root 2 equals b. A is multiplied with root 2, that is here a root 2 equals b into 1 is b. Now root 2 will remain in the LHS and we take it to the a takes the denominator place here. Root 2 becomes b by a. We know that b by a is rational because b and a are integers. That is why they are rational. We also know that root 2 is irrational. Root 2 is irrational because 2 is prime number and the rooting is definitely is irrational. These two, they are proved. Therefore, root 2 can never be equal to b by a. Our assumption is wrong. So we write down that our assumption is wrong, meaning that 1 by root 2 is not rational, it is irrational. That is our answer. Now the second sub-question in question 3 of exercise 1.3 is to prove 7 root 5 as irrational. How do we do that? It is very similar to the first question where we had assumed that that particular question number is rational number. Here also we start the same way. Let us assume 7 root 5 to be a rational number. If this is rational number, that should be equal to a by b, where a and b are co-primes. Very important. This is the only one point which will prove further that this number is irrational. A and b are co-prime. B should never be equal to 0. You know very well, if 0 divides a number, it is undefined. Now you cross multiply 7 root 5 b equals a, or root 5 is equal to a by 7b, whichever way. Ultimately, we need to see that the root of this number remains with the LHS, and the balance should come to the RHS. The whole RHS, that is a by 7b, is rational number. It is rational because a, b are integers, 7 is a number, integer, the whole thing is rational. We also know root 5 is irrational, which is proved. With this, we can find that the given number is irrational. How? Root 5 can never be equal to a by 7b because a rational number can never be equal to irrational number. This is one very good condition to disapprove this. If it is so, we went wrong in assuming that 7 by 5 is a rational number. We write down that our assumption is wrong. Therefore, we can say 7 by root 5 is irrational. This is our answer. Well, we go to third question, 6 plus root 2. The question is, we have to prove that this is irrational. How to prove that? First step is, let us assume 6 plus root 2 is rational. That's the first step. We have to assume that. And if it is proved, then it is rational. If it is not proved, then automatically 6 plus root 2 becomes irrational. There is a way to answer. If it is rational, then this should take the form of a by b, where a and b are co-primes. What is co-prime? Co-prime means it should have only one common factor, that is 1, and b should not be equal to 0. Now let us simplify. Root 2 is equal to a by b, that is this, and take 6 to the RHS. Take the LCM, it becomes a minus 6b. Root 2 is equal to a minus 6b divided by b. We know that a minus 6b by b, the whole thing is rational because a and b are the integers and 6 as it is an integer. The whole thing is rational. Also, root 2, we know, we have already done it, root 2 is irrational. Now, these are the conditions that help us to prove that this number is irrational because root 2 cannot be equal to a minus 6b by b, which is rational, and other one is irrational. Irrational cannot be equal to rational. Therefore, now we say our assumption is wrong. Therefore, 6 plus root 2 is irrational. This is our answer.